there have been two real explosions that have propelled the industry forward. The first one really happened in 1977, and it was the spreadsheet. I remember when Dan Filestra, who ran the company that marketed the first spreadsheet, walked into my office at Apple one day and pulled out this disk from his uh, vest pocket and said, I have this incredible new program. I call it a visual calculator, and it became VisiCalc. And that's what really propelled the Apple II to the success it achieved.
Welcome to Interface Studies. My name is Saleh. The story of the spreadsheet is often told as a business story, centered on software markets, corporate competition, and platform dominance. But what is usually ignored is the spreadsheet as an interface, and specifically what it enables from a design and human-computer interaction perspective. Despite decades of new software paradigms, the spreadsheet interface persists. It refuses to go away. Industry estimates suggest that Excel and spreadsheet interfaces more broadly remain the default tool for analysis, modeling, and reporting. With usage growing over recent years, even as organizations push towards centralized data systems and AI-assisted workflows. Before the spreadsheet, data processing and manipulation were specialized activities handled by dedicated departments, typically operating large mainframe computers. Business users interacted with these systems through a batch processing workflow. They submitted requests, waited for processing, and received results hours or days later. This began to change in the late 70s, with the rise of personal computing and specifically with the release of VisiCalc in 1979. VisiCalc is widely regarded as the first killer application, software valuable enough that organizations purchased the hardware specifically to run it, transforming the Apple II back then from a hobbyist machine into a serious business tool. Conceived by Dan Bricklin and Bob Frankston, VisiCalc, short for Visible Calculator, emerged from Bricklin's frustration with manually recalculating financial models at Harvard Business School. He imagined a magic blackboard where changing one value would automatically update all related values.
I imagined a magic blackboard that if you erased one number and wrote a new thing in, all of the other numbers would automatically change, like word processing with numbers. I imagined that my calculator had mouse hardware on the bottom of it and a head-up display like in a fighter plane. And I could type some numbers in and circle it and press the sum button, and right in the middle of a negotiation, I'd be able to get the answer.
This automatic recalculation concept was the technological breakthrough that enabled agency. We have the feedback loop first. When a user typed a value into a cell, the screen updated instantly. The latency between the thought of, "I wonder what happens if," and the result collapsed from days to milliseconds. Adopting the grid metaphor for the spreadsheet helped in organizing memory into two-dimensional grid of rows and columns. VisiCalc provided a cognitive scaffold that mapped perfectly to the paper ledgers accountants were already using. This was a skeuomorphic design choice. Not in visual decoration, but in cognitive structure. The digital system behaved like its physical predecessor, while vastly expanding its capabilities. After that, as the industry pivoted to the IBM PC in the early 80s, agency was passed to Lotus 123. Created by Mitch Kapoor, Lotus 123 integrated the spreadsheet with database management and charting capabilities. However, its most critical contribution to the philosophy of the grid was its obsession with speed. In the early 80s, hardware was limited, and to maintain the illusion of direct manipulation, which what we're going to talk about later, the feeling that the user is touching the data, the software had to be incredibly efficient. Lotus developers wrote large portion of the software in assembly language and bypassed the operating system to write directly to video memory. This technical decision had a psychological consequence. The grid felt solid, responsive, and immediate. These features in Lotus 123 made the IBM PC the standard for corporate computing. It destroyed VisiCalc's market share by offering a superior, faster implementation of the same agency-driven paradigm. Shortly after that, things changed again. The final evolution of this classic era of the spreadsheet came from Microsoft Excel. Originally released for the Macintosh in 1985 and Windows in 1987. Excel brought the grid into the graphical user interface age. Mouse-based interaction allowed users to select ranges, drag cells, and format data visually, lowering the barrier to entry. By the mid-90s, Excel had effectively won the spreadsheet market, becoming the de facto standard for grid-based analysis. Today, Microsoft reports hundreds of millions of Excel users worldwide, placing it among the most widely used pieces of software in history. The success of the spreadsheet challenges a common assumption in modern software design. It's that simplicity, in the form of reduced responsibility, is always desirable. Sometimes users do want the responsibility over their tool. They want the agency to define the problem and the solution themselves rather than having it pre-packaged by a distant developer. And the question is, why is the spreadsheet the ultimate interface within that world? Why, in the age of endless SaaS applications and dashboards, the grid refuses to give up? There are a few reasons. And before getting into them in detail, there are also problems with the spreadsheet metaphor. That will come later. But let's talk about transparency first. One of the spreadsheet's defining characteristics is the collocation of data and logic. In almost every other programming environment, these two elements are separated. For example, in the traditional code, the logic resides in the text files. The data resides in the memory or a database. To see the data, the programmer must run the code or use a debugger. In SaaS applications, the logic resides on a server, hidden behind the API. The data is displayed in the browser. The user sees the what or the result, but never the how or the calculation. The spreadsheet collapses this separation. Each cell can contain either a static value or an executable formula. The formula bar is the window into the soul of the application. It allows the user to inspect the reality behind the number. If a user sees a profit margin that looks suspicious, they click the cell. Instantly, the dependencies are revealed. The number is derived from revenue minus cost, for example. And this transparency creates trust. In a dashboard, if a number looks wrong, the user feels helpless. They must file some sort of a request for an analyst to go and dig into the data. In a spreadsheet, the user is empowered to audit, trace, and correct the logic. Again, this comes with a price. But this glass box design is the antithesis of the black box nature of modern AI and SaaS applications. After establishing the transparency, let's talk about direct manipulation. Coined by computer scientist Ben Shneiderman, direct manipulation is a user interface style where users act directly on visible objects, getting immediate, reversible feedback. It emphasizes continuous representation of objects and actions, physical or gestural interactions like pointing, dragging, and resizing, rapid incremental operations with instant visual feedback, and easily reversible actions. This reduces cognitive load, builds a sense of control, and makes interfaces more learnable by aligning digital actions with real-world manipulation. Looking at any spreadsheet, we can clearly see the continuous representation of the object of interest. The data is always visible. The physical actions instead of syntax, clicking, dragging, and highlighting, the rapid reversible operations, undo, redo, and immediate feedback. Spreadsheets also align with human spatial memory, giving data a stable physical address. Revenue is not an abstract variable. It's in column B, for example. And from that, we can talk about liveness. In human-computer interaction, liveness refers to systems where program behavior remains visible and continuously updated during editing. In traditional programming, the edit, compile, run cycle breaks the user's flow state. The programmer must hold a mental model of the programmed state while waiting for the machine. The spreadsheet eliminates this distinction. The program is always running. When a user changes a variable, the entire universe of the spreadsheet updates to reflect that new reality. This liveness fosters a sense of play and experimentation. Users can tweak models, finding their way toward a solution rather than having to architect the entire solution in advance. The next thing that we're going to talk about is the low floor, high ceiling principle. Spreadsheets fit with what's called end-user programming. A concept emerged from human-computer interaction and software engineering research in the late 70s and 80s. It's used to describe tools that let non-professional users create or modify software artifacts. It contrasts with traditional programming by professional developers, shifting focus from general-purpose code to task-centric customization, where users directly automate their own work, trading breadth and rigor for approachability, immediate feedback, and control within familiar applications. A successful end-user programming system must balance between accessibility and power. This is often described as the low-floor, high-ceiling principle. The barrier to entry for Excel is 0. If you can type a number into a box, you're using it. You do not need to define variables or import libraries. This allows users to start with simple lists and data entry. Now, as the user's needs grow, the tool grows with them. The progression from data entry to basic sums, logical functions, lookup functions, and pivot tables is a smooth process. High ceiling. Simple tools like to-do apps, for example, have a low floor but low ceiling. You hit the limit quickly. Complex tools like Python or an advanced database have a high ceiling but also high floor. The initial learning curve is steep. The spreadsheet is unique in spanning the entire spectrum, allowing a user to evolve from a novice to a developer without ever switching tools. Now, after acknowledging the extent to which this agency is beneficial, it is necessary to confront its structural weaknesses. The same freedom that empowers users also enables catastrophic errors. Spreadsheets are inherently fragile systems. A single misspecified variable, an incorrect cell range, or one misplaced click can silently rewrite outcomes. What appears to be a neutral interface conceals a form of volatility where representation, this grid of cells, is easily mistaken for reality itself. 3 infamous global incidents demonstrate that. In England's COVID response in 2020, Public Health England processed test results using Excel spreadsheets. They were loaded from CSV files. CSV files are simple text tables where values are separated by commas and each line is a row. Now, when the file was opened in Excel, and that specific incident, the file exceeded Excel's raw limit. Many rows of data were silently dropped. About 16,000 positive cases disappeared from the system simply because the spreadsheet could not display them. The interface provided no warning that data had been truncated. What was visible was assumed to be complete. In the Reinhart-Rogoff austerity study, a core result dependent on an Excel formula applied to the wrong cell range. Several countries were excluded because they fell outside the selected area of the sheet. Formulas operate only on what the user highlights, and Excel does not question whether the selection matches the conceptual dataset or the intent. Correcting the range changed the result to around 2.2% average growth, reversing the paper's headline conclusion and significantly undermining the intellectual value of the study. In JP Morgan's 2012 London whale case, a risk model built in Excel used a sum instead of an average. It was due to a human error. The spreadsheet displayed a single number that appeared authoritative. The underlying logic remained invisible. The result was a severe understatement of risk that contributed to losses exceeding $6.2 billion. Spreadsheets collapse data, logic, and presentation into a single visual grid, rely on manual selection and formula construction, and also provide little feedback when assumptions are violated. This interface makes powerful actions feel trivial and trivial mistakes consequential. The interesting thing is that by 2013, Excel already had core safeguards, named ranges, data validation, protected sheets, and formula auditing tools. The problem was that they weren't applied or enforced. Silent errors can still happen even with experts. We can think of it as attacks that can be only dealt with as 4i approval or through enhanced and rigorous reviews. But even with all this, the reality didn't change. The spreadsheets are still here. The most vital feature of any enterprise application today is the Export to Excel button. This is an escape hatch. It's the escape from a modern invention, the dashboard. Over the last 2 decades, the software industry has shifted decisively toward the dashboard model, driven by the rise of software as a service and the mobile revolution. Unbundling Excel is a concept that's been with us for the last 20 years or so. Startups look at what people are doing in spreadsheets and build a dedicated SaaS application to replace that specific workflow. We see that with Salesforce, Jira, Asana, and many more. And with all of what they offer, users still export data to Excel. There's a certain familiarity and control that this button gives. It's exporting data out of a rigid system of record so that they can manipulate it in a system of agency. Spreadsheets here act as the connective tissue between systems. If the HR system doesn't talk to that payroll system, a human bridges the gap with a CSV export and a spreadsheet. While these SaaS applications offer significant advantages, like centralized databases, multi-user concurrency, and role-based access control, they fundamentally alter the power dynamic. They transform the business user from an architect of the system into an operator of the system. With all its faults, in Excel, if a sales manager wants to add a column to track commute time of prospect, they simply right-click and add it. In Salesforce, the same manager must submit some sort of a request to a system admin, who must evaluate the schema impact, prioritize the ticket, and eventually deploy the change. The business user lost the agency here. They are blocked again by the appliance view of software. Now, the dashboard is great, and it is the interface of the SaaS era. Dashboards are designed for monitoring, though, not modeling. They are based on the Executive Information System concept, a high-level view for decision makers who do not have the time, or were told to that they don't have the time, for digging into the raw data. Modern dashboard design is governed by the 5-second rule. A user should be able to find the information they need within 5 seconds. To achieve this, the designers simplify complex realities into KPI cards, gauges, and traffic lights. But by removing friction, dashboards encourage passivity. A green light on a metric tells the user that everything is fine. stop thinking. It does not invite the user to ask why or what if. It creates a false sense of security. The calculation behind the dashboard widget is also hidden. It resides on the server-side code or the complex query defined by the data team. As we look into the future, there's a tension between this grid and dashboard, and it's entering a new phase with the rise of generative AI. Will AI liberate the business user, or will it become the ultimate instrument of passivity? Now, I've spoken about this many times, but if the ultimate interface of AI becomes the chat window, like asking how were sales last month and getting an answer, the user is removed even further from the data than in a graphical dashboard. Modern tools and agents can source and cite data. That will depend on models and create new costs. And even with that, and after establishing a period of trust with the agent or the model, users don't know about or cannot debug hallucinations. This might lead eventually to total passivity. There is also a counter trend that is emerging, in which AI augments the grid rather than replacing it. New tools are attempting to use AI to lower the barrier to entry for the grid, giving every user the power of a master modeler. In Claude for Excel, for example, we see how it integrates Claude directly into the spreadsheet. It keeps it the same. The user can create a column that categorizes these transactions based on certain keywords, and the AI will write the formula. This future suggests that the grid will remain the fundamental interface. AI will act as some sort of a copilot that can help the user to construct and populate it. It somehow preserves agency while removing the complexity of syntax. We're also seeing a lot of new tools that combine the concept of the grid with some sort of AI. Tools like Airtable, Notion, and Coda. These are modern spreadsheets. They combine the agency of the grid with the relational power of the database. They allow users to toggle between grid view, which is agency, or the Kanban gallery view, which is the dashboard. Users might need both modes at the same time. There are also new types of spreadsheets. Tools like Row Zero focus on bringing big data scale with a billion row capacity to the familiar Excel interface, proving that the paradigm itself is not obsolete. Perhaps only the engine was, and what is needed is a new technical solution. The resistance of the spreadsheet might be revealing a fundamental truth about human-computer interaction. We do not just want to consume information. We want to inhabit it. The spreadsheet endures because it treats the user as an intelligent agent capable of modeling the world. And while the modern trend of SaaS and dashboards offers convenience, safety, and mobile accessibility, it comes at the high cost of agency. It turns active creators into passive consumers. The unbundling of Excel into thousands of rigid appliances has fragmented the enterprise and created a longing for the unified, flexible canvas of the grid, a longing that manifests in the persistence of export to Excel in every single modern tool. Now, the spreadsheet is not perfect. And as the Reinhart-Rogoff error demonstrates, its power is dangerous. It lacks the safety rail of modern software engineering. Yet, somehow, its transparency, liveness, and embodiment make it the ultimate interface for thinking, makes the risk worth taking. And as we move into the AI-defined future, the lesson of the spreadsheet is clear. We must resist the temptation to hide complexity behind simple interfaces that disempower the user. True innovation lies not in doing the thinking for the user, but in giving the user better tools to think with. And I think the grid, in some future form, will endure, because the desire for agency is a fundamental human trait that no amount of dashboard polish or AI polish can extinguish.